Hi everyone. In this video, we are looking at forces and motion from the topic mechanics. This is our first video on this topic, video number 1 on this topic. Say you have a block whose weight is W, for instance, and you place this block on a rough horizontal surface. This line here is a rough horizontal surface. Let me just do something like this to indicate it's rough. So we want to determine the forces that will act on this block when you place it on this surface. Say you applied a force S, and you're pulling, try to pull this block towards this direction, positive X direction. On this surface, this rough surface, this block of weight W is going to exert a force W. A weight force, if it's W here, kilogram, is going to exert a weight force Wg. This G is the acceleration due to gravity. That is the force gravity exerts on every object on Earth. The force that is trying to keep every object to the center of the Earth crust. That is what we refer to acceleration due to gravity. So you multiply the weight by that acceleration force due to gravity, then you get the force here. So because you are trying to pull this block towards the right hand side, and being that this surface upon which this block is sitting on is rough, it has some kind of resistance called friction, frictional force. So you are going against that frictional force. We call it F. Now, this weight, the weight of the block, is acting downwards. It means there is a normal weight on this surface that is equal to the weight acting downwards, which is what we call N. That force, we call it N. So these are the forces that will act on the block. If all these forces, the net forces, is 0, that is, the block is stationary, is in equilibrium, it's not moving. You are trying to pull it here, and the friction on this surface is holding the block from moving. This block definitely is not going up, it's not going down, it's just stationary there. So then we'll say this block is in equilibrium. And because of that condition, this is where Isaac Newton's first law of motion comes in. You know, Newton has 3 powerful laws of motion. We'll use 2 on this topic, 2 of them in this topic, the first one and the second one. The first one says that everybody continues in a state of rest or in motion unless impelled by some external forces that will make it to act otherwise. If something is stationary, it will stay stationary, except you apply imbalanced forces to make it move or do something else. If the object is moving, is in motion, it will continue to move unless some external forces apply to it now to make it to change its motion. So that is the first law of Newton. We'll be using a lot of it in solving problems under forces and motion. But one thing I like to mention here, because of the friction here, this rough surface is applying to this block. That friction, we call it coefficient of friction. This is the symbol, mu. So then if we want to write an equation here, we'll have this force here is equals to mu times N normal. This has to be maximum value. So this is what you get. Keep this in mind, this equation. The frictional force is equal to the coefficient of friction times the normal force. That's what is same, F max. Just keep it in mind. We shall be using it a lot later on. But this is what you get. Now let's look at let's look at a problem. Let's solve one problem and see how these rules are applied. Say, question number 158, number 10. We have a diagram here. We have this diagram. Correct. One force going. You have a diagram here. We have one force going this way, another one going this way. One this way, another one this way. Should be another one up as well. 5qn. N is Newton. That is the unit for force. 50 pm. 50 m, 50 Newton, p Newton. 3 pm, 3 p Newton, and we don't forget to put the arrows indicating how the forces are acting, and q plus 10 m. This is q plus 10 Newton. And the question says, given that the diagram shows a particle acted on by a set of forces. Given that the particle is at rest, find the value of P and the value of Q. This particle is being acted upon by this set of forces and it is at rest. It is in equilibrium. Then you are asked to find the value of Q and the value of P. So, what do we have? What we have here, remember when it is stationary, this force is equal to this force. This force acting upwards is equal to this force acting downwards. That's why it's stationary. It's not moving in any particular one direction. So when we are told that this object here circle something here, these forces are acted upon it, and everything is in equilibrium, it's stationary, it's not moving. You are now asked to find the value of Q and the value of P. This is 50 newtons, the unit for force. This is 5Q newtons, P newtons, 3P newtons, Q plus 10 newtons. Find P and Q. Simple, I know. So because we are told these forces are they are in equilibrium, it means 50 newtons, let's start from with the x-axis, the forces acting horizontally. It means 50, let me ignore the unit here, the newtons, let me leave the ends, is equals to this one here, P. That is our number one. Number two, it means 5Q, we don't know the value of Q, is equals to Q plus 10 for this force, then plus 3P. And this is our equation number two. So 50 equals to P. 5Q equals Q plus 10 plus 3P. So we know P is 50. Straight away, we got one. Let me look at the problem again. 50 PM. Yes. So if P is 50, you just substitute 50 where you see P. So here you have 5Q is equals to Q plus 10 plus 3 times 50, because we are told P is 50. So then you get 5Q equals Q plus 10 plus 150. So this Q, will bring it here, it will be now 4Q. 4Q is equals to, this is 10 plus 150, this will give you 160. So therefore Q is equals 160 all over 4, which is for 40 newtons. So these are your answers. P is 50 newtons, Q is 40 newtons. And it's true, if this is 50, this is 50. So the horizontal movements will cancel. If now this is Q, we are told is 40. If Q is 40, so this is 5 times 40 here, you get 200 here, newtons. And then what do you have here? You have 3P, P is 50, so this is here 150 already, and Q is 40. So 40 plus 50, 40 plus 10 is 50. So you have 50 here. So 150 plus 50 is 200 newtons. So you see, all the forces, they cancel each other. Let's look at the second one quickly. Second problem says that 11. Given that the particle in this diagram is moving with constant velocity v, find the values of P and Q. So there's another one here. 3P minus 2Q. Let me indicate the forces first. 3p minus 2q, and we have something here is moving in this direction, constant velocity. I'll come to that. 25n 2p 25n. This is 25 newtons, 2p plus q, 2p plus q, 20 newtons. 20 newtons. Let me read the question again. The question reads, given that the particle in this diagram is moving with constant velocity v, find the values of p and q. When velocity is constant, it means the speed and direction, they don't change. And therefore, acceleration is zero. That's the interpretation. So it means acceleration here is zero. So now, from what we have here, from Newton's first law, don't forget that law we mentioned that every object continues to rest if it is at rest, and it will continue to be in motion if it is in motion, unless impelled by some external forces that will make it to act otherwise. That's what Newton's first law states. Nothing moves if it is stationary, except you apply some force to it before it can move. And nothing stops if it is in motion, except you apply force on it to stop it. So this is what we are applying. We want you to apply Newton's first law. It's simple, but when we move to advanced problems, then you shall see when this diagram will change. Now we just have four forces here. We shall move on to problems where this surface is inclined, is gonna take an angle, and then they will put some weight on it and some extra forces. Then they will be asking you to resolve those forces. Then things will become different from what you are doing now. But you need to have this concept from the beginning. You need to understand these little things so that when we go to harder problems, you will find it easier to understand what is happening. So again, we know this is stationary. The forces cancel, all the net forces. So it means this normal force is equal to the weight of this object. So therefore we have let me start with the 20. 20 newtons. Let me ignore the unit for now, yeah? This is equals to 3p minus 2q. This is our equation 1. And we have 25 newtons equals 2p plus q. This is equation number 2. Now, this is a simultaneous equation. You can solve simultaneous equations. You have two options here. Either you multiply the bottom equation by -2, then you subtract one from the other, or you already have q here, you make q the subject of the formula, and then you substitute in the first equation. So let's take the latter case. From equation 2, that's what I mean when I say from 2. From 2, from this one, q is equals to 25 minus 2p. And we'll call this equation 3. Now put equation 3 in equation 1. We are now putting this equation q in equation 1. So what do you get? Equation 1, you have 20 equals 3p minus 2q. But instead of q now, we have 25 minus 2p. And then let's solve. So you have 20 equals 3p minus 2 times 25. This is 50. You have minus, minus, there's a bracket. So this minus sign changes now to plus when you clear the bracket. So this is going to be now 2 times 2. So this is going to be plus 4p. So you have 3p plus 4p. This is 7p. And you have minus 20 here. You have plus 20 here. So if you bring the minus 50 here. If you bring the minus 50 over there to the 20, collecting like terms, it's going to be 20 now plus 50. So this is going to be 70 equals 3p plus 4p. This is going to give you 7p. So you just divide by 7. You divide by 7. This cancels this. So your answer here will become 10. 10 newtons. P is 10. So if P is 10, you now come to this equation. So put P equals 10 in equation 3. Equation 3 says Q equals 25 minus 4P. Instead of P now, you have 10. That's correct. 25 minus 2, not 4. Minus 2. So now you have 25 minus 20. So this gives you 5. Q is 5. So Q is 5 newtons. So let's see whether we are right. If Q is 5 and P is 10, so you have 2 times 5, 2 times 10 is 20, plus 5, 25 is equal. So if P is 10, this is 30 here. Q is 5. So this is 10. 2 times 5 is 10. 30 minus 10 is 20. So that's correct as well. Thank you for watching. Bye bye. We shall be solving more of these problems, forces and motions. There's a lot of problems involved in this topic. We shall try to cover all of them. Thank you for watching. Bye bye.